Hydrocarbons are organic compounds that are made of only hydrogen and carbon. Hydrocarbons can be either saturated or unsaturated. In saturated hydrocarbons, there is no pi bond. In unsaturated hydrocarbons, there is at least one pi bond. So it can be a double bond, carbon-carbon double bond, or it can be carbon-carbon triple bond. If it's double bond, for example, in ethylene, there is one pi bond here. In acetylene triple bond, there is 1 and 2 pi bond. In this molecule, benzene, there is 1, 2, and 3 pi bonds. So these three compounds, ethylene, acetylene, and benzene, they are all unsaturated hydrocarbons. Unsaturated because they have at least one pi bond. Hydrocarbon because they're only made of hydrogen and carbon. But this molecule, ethane, is saturated hydrocarbon. It doesn't have any pi bond and it is only made of hydrogen and carbon. Saturated hydrocarbons are also called alkanes. These three molecules are examples of saturated hydrocarbons or alkanes. They don't have any pi bond and they are made of only carbon and hydrogens. The suffix ane, A and E is used for saturated hydrocarbons. The difference between these three hydrocarbons, propane, butane, and pentane, is the number of carbons. Many organic compounds have common names. You can see here this molecule is formic acid, urea, morphine, and barbituric acid. But there are millions of organic compounds, and we cannot memorize millions of names. For that reason, chemists decided to come up with a system to name organic compounds. Researchers, and they called this system IUPAC system. Stands for International Union of Pure and Applied Chemistry. We can use IUPAC system to name alkanes. First, we have to find the parent chain. What is the parent chain? It is the longest consecutive chain of carbons. For example, in this compound, this is one carbon chain. It has 1, 2, 3, 4, 5, and 6 carbons. Is this the longest chain of carbons? No. The second chain is this chain. Is this the longest chain? 1, 2, 3, 4, 5, and 6. No, this one is not the longest chain either. This is another chain of carbon. Is this the longest chain? It's 1, 2, 3, 4, 5, 6, 7, and 8. Is this the longest chain? We don't know. And the next chain is this one. it is 1, 2, 3, 4, 5, 6, 7, 8, and 9 carbons. This one is the longest carbon chain in this molecule. So the parent chain in this molecule has 9 carbon atoms. Then we have to find the Greek prefix that corresponds to the number of carbons in the parent chain. If the parent chain has only 1 carbon, the prefix that we use is meth. If the parent chain has 2 carbons, the prefix is eth. If parent chain has 3 carbons, prop. If parent chain has 4 carbons, but. If parent chains have 5 carbons, pent. 6 carbons, hex. 7 carbons, hept. 8 carbons, oct. 9 carbons, non. And 10 carbons, 10. And since we are talking about saturated hydrocarbons or alkanes, name ends with A and E. So if parent chain has 1 carbon, name of alkane is methane. 2 carbons, ethane. 3 carbons, propane. 4 carbons, butane, and keep going. You have to memorize the first 10 parents. Methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. You have to memorize these 10 parents. Okay, here the first molecule. This is the parent chain, and it has 1, 2, 3, 4, 5, 6, 7, and 8 carbons. So the parent chain for this compound is octane. For the second compound, this is the parent chain, and it is 1, 2, 3, 4, 5, 6, 7, 8, and 9. And the parent chain is nonane. If there is more than 1 possible parent chain, like 2 chains with the same number of carbons, and they both are the longest chain, then you have to choose the one with the most substituents, with the most side chains. For example, here in this molecule, there are 2 chains with 7 carbons, and which one is the parent chain? If we pick this as the parent chain, it has 1, 2, and 3 side chains. If we choose this, the other chain, as the parent chain, it has 1 and 2 side chains. And based on IUPAC system, we have to choose the one with more substituents as the parent chain. So this one is the parent chain, the one on the left, because it has 3 substituents, 3 side chains. If the parent chain is a ring, we add the prefix cyclo to the beginning of the parent name. For example, here we have 3 carbons. The molecule has 3 carbons, and it is a ring, and it is saturated. So it's an alkane. It's propane because it has 3 carbons, And we have to add cyclo to the beginning of the parent chain. It is cyclopropane. The next molecule has 4 carbons. It's butane, and it's a ring. We add cyclo, it is cyclobutane. The next one has 5 carbons. It is pentane. It's a ring, so we add cyclo, it is cyclopentane. This molecule has 6 carbons, so it is hexane, and it's a ring. We add cyclo, it is cyclohexane. Identify and name the parent chain in each compound. We know that the parent chain is the longest carbon chain. For A, this is the longest carbon chain. And it is 1, 2, 3, 4, 5, and 6 carbons. So parent chain for A is hexane. For the second molecule, the longest carbon chain is this chain: 1, 2, 3, 4, 5, 6, and 7. It is heptane. The parent chain is heptane. For C, the longest carbon chain is this chain: 1, 2, 3, 4, 5, 6, 7, and 8. It is octane. Indeed, the longest chain is this chain: 1, 2, 3, 4, 5, 6, and 7. It is heptane. And finally, for E, this ring is the parent. It has 5 carbons and it's a ring. So the parent for E is cyclopentane. After finding the parent chain, we have to identify and name the substituents. Substituents are the side chains. In this molecule, this is the parent chain, and it has 3 substituents. One substituent here, this is the second one, and this is the third one. To name the substituents, we count the number of carbons and end it with YL. For example, here, this substituent, this side chain, has only 1 carbon. So it is methyl. Met for 1 carbon. And since it's a side chain, name ends with YL. This is a methyl group. This one on top has 2 carbons. Starts with F, and ends with YL. So this is an ethyl group. The third side chain has 3 carbons. Starts with prop and ends with YL, propyl. So this compound has 3 side chains, a methyl group, an ethyl group, and a propyl group. If there is a ring in the molecule, this ring can be the parent or it can be just a side chain, and it depends on the number of carbons. For example, here, ring has 6 carbons, and this chain has 3 carbons. Ring has more carbons, so ring is the parent, and this is the side chain. It's a propyl. So this is propyl cyclohexane. In the molecule on the right side, ring has 3 carbons and chain has 4 carbons. A chain has more carbons and it is the parent, which means the ring is a substituent. It's a side chain in this molecule. If the ring and chain have the same number of carbons, ring will be chosen as parent. Sometimes the side chain has a complex structure and we have to use the IUPAC rules to name the side chain, but you don't have to do this in this class, so you don't have to worry about that. And some side chains have common names that you have to memorize. For example, if the side chain has 3 carbons, it's either propyl or isopropyl. If it connects to the parent on the middle carbon, on the second carbon, it is isopropyl. So you have to memorize isopropyl. And these are other side chains with common names that you have to memorize. Secondary butyl, isobutyl, tertiobutyl, isopentyl or isoamyl, and neopentyl. So you have to memorize the common name for these side chains. After finding the parent chain and identifying and naming the side chains, we have to number the parent chain to identify the location of each side chain. We can number the parent chain from left to the right or right to the left, but which one is correct? It depends on the location of the substituents. Okay, if there is only one substituent on the parent chain, if there is only one side chain on the parent chain, we number the parent chain in a direction that gives this substituent the lowest possible number. So for example, in this molecule, the parent chain is pentane and there is one side chain, a methyl group. I can number from the left side 1, 2, 3, 4, and 5. If I number from the left side, the substituent, the side chain, is number 4. I can also number from the right side 1, 2, 3, 4, and 5. So if I number the parent chain from the right side, the substituent will be on carbon number 2. And based on IUPAC rules, we have to give the substituent the lowest possible number, which means this is wrong and this is right. Another example is down here. The parent chain has 7 carbons. We can number from the left side or the right side. If we number from the left side, the substituent will be on carbon number 2. If we number from the right side, right to the left, the substituent, the methyl group, will be on carbon number 6. Again, when there is only one substituent, we should number in a direction that gives the substituent the lowest possible number. And 2 is smaller than 6. So this is wrong and this is right. If there is more than one substituent, then we number in a direction that gives the first substituent the lowest possible number. So here in this molecule, the parent chain has 6 carbons, hexane. We can number from the left side 1, 2, 3, 4, 5, 6. So the substituents are on carbon 2 and 4. The first substituent is on carbon 2. Or we can number from the right side 1, 2, 3, 4, 5, and 6. So the substituents are on carbon 3 and 5. The first substituent is on carbon 3. And IUPAC rules tells us that the first substituent should have the lowest possible number, which means this is wrong and we have to number from the left to the right. Another example here. The parent chain is heptane. We can number from the left to the right or right to the left. There are 3 substituents, 3 methyl groups. Okay, from left to the right, if we number from left to the right, the methyl groups are on carbon 2 and 5 and 5. And if we number from the right to the left, the substituents, the methyl groups are on carbon 3. 2 of them are on carbon 3. And the third one will be on carbon 6. We should give the first substituent the lowest possible number. If we number from left to the right, the first substituent is on carbon 2. If we number from right to the left, the first substituent is on carbon 3. And 2 is smaller than 3. This is wrong. And we have to number from left to the right. If there is a tie, then the second substituent should get the lowest possible number. For example, here, if we number from right to the left, the methyl groups will be on carbon 2, 3, and 6. 2, 3, and 6. If we number from the left to the right, the methyl groups, the substituents, will be on carbon 2, 5, and 6. 2, 5, and 6. But the first substituent is on carbon 2. And it doesn't matter if we number from right to the left or left to the right. So there is a tie. Now we have to check the second substituent. The second substituent here is on carbon 3, but for the second one is on carbon 5, and 3 is smaller than 5. So this is incorrect, and we have to number from the right to the left to give the second substituent the lowest possible number. We use the same rules for cycloalkanes. Like here, from left to the right, the side chains, the methyl groups will be on carbon 1 and 1 and 3. From right to the left, it will be on carbon 1, 3, and 3. So the first number is 1 for both directions, for either direction. There is a tie. Now we have to check the second substituent. The second substituent should have the lowest number. And we have 1 and 3. 1 is lower than 3, smaller than 3, which means this is wrong. And we have to number from the left to the right. And finally, we list the substituents before the parent chain in alphabetical order. Okay, let's name this compound. We can, the parent chain is heptane. It has 7 carbons and it has 3 substituents, 3 side chains. We can number from the left to the right. Or right to the left. And the direction that gives the first substituent the lowest number is the direction that we should use, which is left to the right, because it gives the methyl groups number 3. If we start from right, it gives the ethyl group number 4. Okay, so this is wrong. Now to name this compound, name of the parent chain is heptane. It has 3 side chains, 3 substituents, 1 ethyl group and 2 methyl groups. And we put the side chains, the substituents, in alphabetical order. So first comes the ethyl group. It's 4. Ethyl group is on carbon number 4. 4 ethyl. There are 2 methyl groups. They're both on carbon number 3. 3 and 3 dimethyl. Di means there are 2 methyl groups. So it's 4 ethyl, 3 and 3 dimethyl heptane. When we are listing the side chains before the parent chain in alphabetical order, we ignore the prefixes except for iso, okay? So here we only care about ethyl, E, and methyl, M. And we ignore the prefix before the methyl group. We ignore di. Now let's name this compound. The parent chain for this compound is nonane. It has 9 carbons. 1, 2, 3, 4, 5, 6, 7, 8, and 9. If we number from the left to the right, then the first substituent will be number 3. So we have to number from the right side to give this first substituent the lowest possible number, which is number 2. So the parent chain is nonane. and it has 1, 2, 3, and 4 side chains or substituents. 2 of them are methyl groups. One methyl group is on carbon 2 and the second methyl group is on carbon 7. So it's 2 and 7 dimethyl. And the other 2 substituents are ethyl groups. This is one ethyl group on carbon 3 and this is another ethyl group on carbon number 4. So it's 3 and 4 diethyl. We know that we have to list the substituents before the parent chain in alphabetical order, and we should ignore the prefixes. So it is 3 and 4 diethyl. Ethyl comes first. 2 and 7 dimethyl nonane. For large and complex molecules like this molecule, the IUPAC name is also large and complex. Look at the IUPAC name here. So for these type of molecules, often the trade names are used. For example, the trade name for this molecule is Nexium.